Dear viewers, in this class we are going to discuss about the prevention of reheat cracking. I welcome you to my channel Welding Education. Hope you have watched my previous lecture on the reheat cracking phenomena in low alloy steel and austenitic stainless steel, and this lecture is in continuation with that lecture. Now, prevention of reheat cracking I'll be discussing this lecture. First is the composition control, because what we say that because of the strong secondary carbide former presence, the reheat cracking is taking place. So this reheat cracking can be eliminated or reduced by selecting a steel with low susceptibility to reheat cracking. So choosing a composition that uh, possesses or that contains less secondary carbides elements. Secondary effect of welding conditions, because we also found that the grain growth is the main cause for the reheat cracking to occur. So the control over the grain growth can be done by controlling the weld heat input to reduce the grain growth effect and effect of welding condition. So there is a compositional parameter to evaluate the weldability reheat cracking. So there are various parameters like delta G parameters, PSR parameters, and MCF parameters. These parameters are compositional parameters. The composition of the uh, material is checked to found whether the crack will happen or not, or reheat cracking will take place or not. So delta G parameters considers chromium, molybdenum, vanadium. If the delta G is greater than 0, the material is considered to be susceptible. Then second is a PSR parameter. PSR parameter continues considers in formula chromium, copper, molybdenum, vanadium, niobium, titanium effect. If PSR value is greater than 0, the material is deemed to be susceptible. Then thirdly, there is a third parameter known as MCF parameter. MCF parameter considers a silicon, copper, phosphorus, arsenic, stainless, uh, and stbium effect in its formula. So you know this arsenic, stainless, and stbium are the low melting point detecting, and phosphorus as well. So this increase in MCF value decrease in rupture ductility as measured by elongation in the hot tensile test. So these are the compositional parameter to evaluate the weldability reheat cracking. Now, what are the ways to prevent reheat cracking? In continuation with our topic, control of residual stresses. Because you know, during welding of thick section, if proper preheating, control of bead size or the welding sequence is maintained, then there will be proper distribution of the heat. And while welding thick section, one has to be careful to control the residual stresses. Second, fourth is the effect of stress concentration. So any geometry or a design like sharp edges, blending, so it's raises the stresses. So this kind of design should be avoided in a well design. So this will reduce the stress concentration on the areas. Control of the stress relaxation, because we also found that the um, carbide precipitations has to do with the temperature. So it is possible to avoid the formation of crack by the managing the stress relaxation time, and if there is any residual stresses are present. This practice is difficult for low alloy steel, but with the austenitic stainless steel it can be applicable because the carbon precipitation is taking place high temperature. So if the weld is held below the temperature, uh, this temperature particularly, uh, for some time to reduce the stresses. So where the carbide precipitations are taking place, if the weld metal is kept below this temperature range, the residual stresses or the stresses built up can be avoided. So overall control of stress relaxations can happen. The next option is the buttering. So applying a, ductile weld metal, or say the nickel base alloy, use of nickel base alloy uh, to the susceptible base metal, where the composition of butter lead is resistance to reheat cracking. So there are some techniques. So in a summary, the techniques are composition control, effect of welding condition, and calculation of compositional parameters to avoid the weldability reheat cracking, and control of the residual stresses, effect of stress concentration, control of the stress relaxation, and buttering. These are the techniques one can use to get rid of the reheat cracking fan problem. Now these are my references I have used to make this presentation, and hope you have enjoyed my lecture on this reheat cracking low alloy steel and austenitic stainless steel. And for any welding procedure, weldability, filler metal selection, dissimilar metal joining related queries, you can write to me on my WhatsApp number 9879332449, or over the email purvesh2578@gmail.com. I'm involved into technical blog writing. I'm an author of the technical blog www.weldingknowledge.co.in, and you can subscribe this blog to receive uh, uh, updates on the question answer post and my interaction with the industrial professional. So thank you for watching my video, my lecture once again. Happy learning.